Good morning, everyone. Hope you're all doing well. Today we will start with a new unit, chemical reactions and equations. Chemical reactions take place in nature in our daily lives as well as in labs. All chemical reactions involve a chemical change. At the end of this lesson, you will be able to identify the reactants and products in a chemical reaction, list the signs of a chemical reaction, state the law of conservation or Lavoisier's law of matter, interpret a chemical reaction and write the word equation, write and balance a chemical equation. As you already know, chemical reactions involve a chemical change where the identities or properties of the substances involved vary. Thus, new substances are formed. Let's take the following example. Vinegar is added to the flask. Then a chalk is placed in this flask. These two substances react with each other to produce new substances that are carbon dioxide, water, and a chemical called calcium acetate. In a chemical reaction, the starting substances that react with each other are called reactants. The new substances that are produced are called the products. The properties of the reactants are different from those of the products. Chemical reactions can be identified by several signs, such as change in color of the reactants as shown in the figure, release of a gas, such as carbon dioxide or hydrogen, formation of a precipitate that is an insoluble solid formed at the bottom of the flask, and exchange of heat. There are other signs such as a smell. Note that some chemical reactions don't show any of these signs. As we mentioned before, some chemical reactions are accompanied by exchange of heat. Based on this, chemical reactions are divided into exothermic reactions that release heat and there is an increase in temperature. Example, combustion reactions which involve the burning of any chemical. Or endothermic reactions that absorb heat and there is a decrease in the temperature. Example, decomposition or breaking down of a chemical. In application 1, you are asked to name the reactants and products in the given reactions, then indicate the sign of each reaction. Don't forget to pause the video, then check your answers. The following experiment is performed to explore Lavoisier's law, who studied the variation of mass during a chemical reaction. Two reactants, calcium chloride and sodium sulfate, are placed together in a flask. As you can observe, the mass of these reactants is 184.34 grams. The contents of the flask are shaken and left to react. As a result, two new substances, sodium chloride and calcium sulfate, are formed. The flask is again placed on a balance. The mass of the products remains 184.34 grams. Therefore, Lavoisier stated that the mass or the amount of matter is conserved in a chemical reaction, which means that it doesn't change. So Lavoisier's law states that in a chemical reaction, matter is neither created nor destroyed. It is only changed or transformed. The mass of reactants and products is equal, thus it is conserved. In application 2, you're given that hydrogen and oxygen react to produce water. In part 1, you have to calculate the mass of water produced, while in part 2, you have to calculate the mass of oxygen used. Read the given carefully and don't forget that you have to apply Lavoisier's law and simple maths equations. So you start by stating Lavoisier's law. According to Lavoisier's law, matter is neither created nor destroyed. Mass is conserved. Then mass of reactants is equal to mass of products. In part 1, the mass of water, which is the product, is the sum of the mass of the two reactants. While in part 2, to calculate the mass of oxygen, that is one of the reactants, we subtract the mass of water and the mass of hydrogen. Each chemical reaction can be described by a word equation that shows the names of the reactants and the names of the products. Reactants are placed before the arrow, and the products are after the arrow. For example, hydrogen and nitrogen gas react with each other to produce ammonia gas. The symbol plus means and, while the arrow means produces or gives. Keep in mind that the number of reactants and products differs between reactions. In application 3, for each of the following reactions, write the word equation. Don't forget, plus means and, while the arrow means produces. Reactants are always placed before the arrow, and the products are placed after the arrow. To express chemical reactions more easily, scientists use chemical equations. In a chemical equation, we use symbols and formulas. Let's consider the previous reaction. We will write the chemical equation of this reaction. So the formula of hydrogen is H2, and that of nitrogen is N2, and the formula of ammonia gas is NH3. So the chemical equation is H2 plus N2 gives or produces an H3. Remember that these numbers are called subscripts, and they show the number of atoms. Complete each chemical equation with the proper symbol or formula by referring to the word equation given. In exams, the formula for compounds that you do not know will be given. Sometimes you have to use the crisscross method explained in previous lessons to find the formula of the compounds. In order to obey Lavoisier's law, the number of each type of atom must be equal in the reactants and in the products. Therefore, a chemical equation must be balanced. A balanced chemical equation also uses symbols and formulas. To balance a chemical equation, we must use coefficients, which are numbers placed before the compound or element. Let's explore how to balance a chemical equation. Consider the previous reaction. We will represent it using this model, where the gray balls represent the hydrogen atoms and the blue balls represent the nitrogen atoms. So the number of hydrogen atoms in the reactants is 2, and the number of nitrogen atoms in the reactants is also 2. However, the number of hydrogen atoms in the products is 3, while the number of nitrogen atoms is 1. Then this equation is not balanced. So how can we balance this equation? First, we write the unbalanced chemical equation. Second, we count the number of each type of atom in the reactants and in the products. To balance the number of atoms, we can only multiply by a coefficient. For nitrogen to be balanced, we can multiply by 2 on the products side. We place number 2 before NH3 as a whole compound. Now the number of hydrogen atoms in the products is 6. To balance it, we have to multiply by 3 on the reactant side. So we place number 3 before H2. Now the reaction is balanced because we have 6 hydrogen atoms in the reactants and 6 hydrogen atoms in the products. We also have 2 nitrogen atoms in the reactants and 2 nitrogen atoms in the products. Keep in mind that we cannot change the subscript because we will be modifying the formula of the compound. Let's take another example. A reaction between zinc and hydrogen chloride produces zinc chloride and hydrogen gas. The unbalanced equation is Zn plus HCl produces ZnCl2 plus H2. First, we count the number of atoms of each element in the reactants and products. For zinc, the number of atoms in the reactants and products is equal, so it is balanced. However, for chlorine, the number of atoms in the reactants is 1, while in the products it is 2. To balance the number of atoms of chlorine, we can multiply 1 by 2 and place 2 as a coefficient in the reactants before HCl. Now the number of hydrogen atoms becomes 2, so it is balanced since we have 2 hydrogen atoms in the products. Pay attention to the following mistakes whenever you are balancing chemical equations. Always place the coefficient before the formula or symbol, and never modify or change the composition of the substance by changing the subscript. Consider the following 3 examples of hydrogen chloride. The first 2 are wrong because we have changed the subscript, and so we have modified the composition of the substance, whereas the third one is correct because we placed the coefficient before the formula. Now you are ready to solve application 5, where you have to balance the following chemical equations. Remember, to balance a chemical equation, you have to practice a lot and use trial and error method and some logic. So don't give up easily. Please study the notes and practice well, especially balancing a chemical equation. Then open your books to page 102 to solve exercises 3 and 4, parts 1 to 4. Take care, everybody, and stay safe.